Hello students, in today's class we are going to discuss competitive part on hybridization and valence shell electron pair repulsion theory. Let us have the first question. In the first question we are having fluorine molecule is formed by fluorine atomic number, if you see it's 9, and the electronic configuration 1s2 2s2 2p5, right? So the outermost electrons are present in p orbital, and the outermost shell contains 7 electrons. In order to become octet it requires 1 electron, right? And one of the p orbital of a fluorine will be overlapping with another p orbital, but we have to remember that in fluorine there is a formation of a sigma bond, and according to this condition it will be pz orbital about the internuclear axis, which will be overlapping in the axial format, right? Because we know that if it was px, it leads to the formation of lateral overlapping. Px and py are involved in lateral overlapping that are resulting in the formation of pi bond, right? So lateral overlapping is also called as sideways overlapping, right? And if you see the options here, the fluorine molecule is formed by the axial pp overlap, right? So this is the correct answer. Sideways overlap is not possible because fluorine does not contain any pi bond. Here the option C, if you see, there is axial, but it is revealing about S and P, but in case of fluorine the sigma bond is formed between PP overlap, not the S and P overlap. So this is also not possible. And the overlap of two sp2 hybrid orbitals. Okay, in case of a fluorine there is no hybridization. Okay, there is only water overlapping takes place. Is it clear? So this is also not possible. Now let us move to the next question. Which of the following phenomena will occur when two atoms of the elements having a same spin of the electron approach for bonding? Students, whenever two atoms are coming, okay, let us take hydrogen only. Okay, whenever two atoms are coming for bond formation, for hydrogen we see there is one electron, and other hydrogen we can see that there is another, but whenever they are approaching for bonding, their spin should be opposite. Okay, this is in upward direction, this is in downward direction. Okay, that is the condition. Okay, but here it has been mentioned as same spin of electron. When such conditions, same spin are there, then obviously we can say that orbital overlap will not occur. Okay, orbital overlap will not occur. When orbital overlap will not occur, it reveals that bonding will also not occur. Okay, so correct option is C, that is both A and B are what correct. Remember students, whenever two atoms of elements having same spin of electron, if at all if they are approaching for bonding, then there is no bonding and there is no orbital overlap, right? And we'll move to the next question. In the next question, the percentage of S character, in hybrid orbitals sp, sp2 and sp3 follows the pattern. We know that, okay, if at all if I take here sp and here sp2 and here sp3, right, you can see here there is only one S and here there is only one P. So the percentage of S in sp is 50%. In case of sp2, if you take here P is 2 and S is only one time. Okay, and if you calculate a percentage of S will be here 33.3%. Percentage of S is 33.3%, and in the case of sp3, percentage of S is only 25%. Okay, so follows the pattern they are asking. Okay, and if you see here the sign in this question, okay, in these two, okay, because here they are mentioned equal to, so this I cannot consider, and if at all if I see here also it is equal, so I will leave these two options and I'll concentrate only on this. Okay, the sign it has been mentioned as greater. It means we have to write in what decreasing order, and in decreasing order, that is first comes sp, then comes sp2, and then comes what sp3. So therefore the correct option is option B, right? The percentage of S character in hybrid orbitals sp, sp2 and sp3 follows the pattern, that is option B. Now let us see the next question. In the next question, the bond angle in HOH in ice is closest to, right? So if you take the HOH, it is water molecule, and here we can see that there are two lone pair of electrons, right? If these were bonding electrons, then the bond angle would have been 109 degree, then followed by water 28 minutes, right? Because of these lone pair of electrons, the bond angle has been reduced. Okay, this has been reduced to water 104.5 degrees, right? Is it clear? And now the question is the bond angle of water in ice. Okay, in ice is closest to. Remember student, this is a water molecule, but when it comes to question with respect to ice, in ice there is a hydrogen bonding. In ice there is hydrogen bonding, and because of this hydrogen bonding, the water molecules in ice have arrangement of water tetrahedral in nature. So therefore we can say that in case of what ice, the tetrahedral nature is obtained. In case of water also there is hydrogen bonding, but it is much more stronger in the case of what ice. As a result, the bond angle in water the bond angle in ice is closest to 109 degrees. We'll move to the next question. The structure and hybridization of SiCH3 4 times. Okay, so silicon is coming with respect to the carbon family. Okay, so carbon family, so here carbon, then comes what, silicon, then comes a germanium, then comes a tin, and then comes a lead Pb. Okay, so valency, group valency is what, 4, so therefore silicon is having silicon is having CH3 4 times. So 1 CH3, this is the second CH3, this is the third CH3, and this is the fourth CH3. Okay, and if you observe carefully, it is a tetrahedral in nature, so therefore the shape is tetrahedral here, and the bond angle is 109 degrees 28 minutes, and the option is option D, tetrahedral sp3. And now we'll move to the next question. In the next question we can see that sp3 hybrid orbital contains, right? So in sp3, if I write here sp3, total number of orbitals are 4. Total number of orbitals are 4. In that they are asking a question. Okay, sp3 hybrid orbital contains. Okay, can you see in all the 4 options they are concentrating on s character? Okay, they are concentrating on s character, so therefore we have to find out percentage, or you can just say what sp3 hybrid orbital contains how much percentage, or what s character, right? So here s is only one time, so therefore I will take 1 s. Total number of orbitals in sp3 are 4, right? It becomes what, 1 by 4, right? If at all if they ask a percentage, then it would have been what, multiplied by what, 100, right? So here if at all if I simplify, then this becomes 4 ones and this becomes 4 25s, so the percentage would have been what, 25%. So according to this, sp3 hybrid orbital contains 1 by 4 s character, 1 by 4 s character, or 25% of s character. And let us have the next question here. In the next question we can see that the CCl4, okay, carbon tetrachloride, the 4 valencies. Okay, we know that CCl4, okay, carbon is a tetravalent, the 4 chlorine atoms, which are nothing but the bonding atoms, are directed towards the corners of option D. Okay, direct answer, tetrahedron, because carbon valence is a 4 bonding atoms are there, so the bond angle is 109 degree 28 minutes and is nothing but a tetrahedron. Is it clear, students? Okay, next question number 8. In which of the following the angle between the two covalent bonds is largest? Okay, now one thing we have to consider, students, in case of water there are 2 lone pair of electrons, in case of ammonia there is 1 lone pair of electron, right? And as we move from left to right in the periodic table, we should note that the number of lone pairs are increasing. Okay, the number of lone pairs are increasing because atomic number of nitrogen is 7 and it is forming what? Ammonia. Atomic number of oxygen is 8 and it is forming water molecule. So 7 and 8, when we move from left to right, we can see ammonia molecule formation and then water molecule. In case of ammonia there is one lone pair, in case of water there is two lone pair. Increase in the number of lone pair of electron decreases the bond angle. This concept we have to remember. Of course, the hybridization in case of oxygen of water, that is also sp3. In case of ammonia, that is also sp3, right? And in case of methane, that is also what? sp3, right? But because of the presence of a lone pair of electrons in a water molecule, rather than being 109 degree 28 minutes in water, it has been confirmed that it is 104.5 degrees, right? In the case of ammonia, it is 107 degrees, and here in the case of methane there are no lone pair of electrons, so the bond angle in the case of methane it is 109 degrees 28 minutes, right? This is also sp3. But now if you see this CO2, option CO2, carbon dioxide is a linear molecule. Okay, carbon dioxide is what? A linear molecule, C double bond O. Now if a linear molecule is there, what is the hybridization? Hybridization is sp. Carbon hybridization here, it is sp, 50% of S character and 50% of P character, and the bond angle is what? 180 degrees, right? So one should remember, as the percentage of S character goes on increases, bond angle also goes on what? Increases. Is it clear, students? So here the option is what? Correct option is option C, that is CO2, where the angle between the two covalent bonds is largest. In this question, which has the minimum bond angle? So students, let us find it out. In case of option D, it is methane, so here the bond angle is 109 degree 28 minutes. In case of ammonia, it is 107 degrees. In case of water molecule, it is 104.5 degrees, right? Now if you see this water and ammonia and carbon, okay, that is what methane, okay, the central atom, okay, carbon or that of what? Nitrogen or that of oxygen, they all are coming from a second period. But if you see the option B, here it is a sulfur whose atomic number is a 16, it is coming from third period. So third period means so I can just write it as down the group. Okay, down the group, what increases? Size increases, size goes on increases. And moreover, sulfur is belonging to oxygen family. We know that first comes oxygen, then comes sulfur, then comes selenium, then comes tellurium, then comes polonium. Okay, this is a 16th group of family. Down the group size increases, and down the group electronegativity goes on decreases. Okay, when these two conditions if you consider, when size is going on increasing, okay, so this oxygen, this is sulfur, this is selenium, this is tellurium, and this is polonium, when electronegativity goes on increases, okay, the bonding pairs of electrons which are associated with the atoms, okay, under that condition the bond angle will be what? Minimum. So according to this concept, our answer is H2S. So H2S will be having minimum bond angle. So let us move to the next question. In the next question, students, there is one correction here. Which of the following geometry is associated with? Okay, so after this with, there should have been one formula, that is a PCl5. Okay, which of the following geometry is associated with PCl5, right? So in order to find the geometry, I will be giving you one simple trick to calculate hybridization as well as lone pair of electrons. A very simple trick, okay, that is hybridization is equal to 1 by 2 square bracket, then the V, okay, this is nothing but a number of monovalent species that are linked with what? The central atom, okay, not monovalent, I just want to write here this one. Okay, I will just call it as what V, that is valency of the central atom, then followed by plus the M. I will write this M is number of monovalent atoms that are linked with the central atom. Then I will write minus C. If it is a cation, how many electrons are lost? Then I'll write it as minus C. And if it is anion, then I won't write it as plus A. Now this is the formula to calculate hybridization. Okay, what is V? V is nothing but what? The valency of the central atom under investigation. M is the number of monovalent atom that are linked with the central atom, and C is nothing but what? Charge. If it is cation, then it is a charge, means it has cation, means we have to remove that how many electrons, and if it is anion, then it has gained electron, and here it becomes what? A plus, right? So I want the question of what? PCl5. So PCl5 hybridization is equal to 1 by 2. Valency of a phosphorus, it is a nitrogen family member, that is, so valency is 5, plus number of monovalent species, so there are 5 Cl atoms that are linked with what? Phosphorus. So I will write here what? 5. And PCl5 is a neutral molecule, neither cation, neither what? Anion. So I am not bothered about what? That cation and anion. So if you see, H is equal to 5 plus 5 is equal to 10 by 2, and 10 by 2 is nothing but what? 5. This 5 is a steric number. What is that number? A steric number. Okay, now how to analyze this 5? I will write here 5 in the form of what? S, then followed by P3, then followed by D. Can you see this S is 1 and 3 P are there. Now it becomes what? Of 4. After P3, which is having our alphabet, that is what? D. So therefore it becomes what? Plus 1, and that is nothing but what? 5. 4 plus 1, 5. So altogether it becomes what? S P 3D, right? Now if I take this 5 and I will write here what? Minus. In PCl5, okay, there are only bonding electrons present. Okay, can you see here 5 bonds are present? So 5 minus 5, it is 0, and this 0 indicates there are no lone pair of electrons. This concept is very important, students. What is that? So I got here the steric number 5, and if I subtract from that the 5 bond pairs, then we will get 0. It means there are no lone pairs, right? And when it is 5, we are having sp3d hybridization, and if it is sp3d hybridization means the option, the geometry is what? A trigonal bipyramidal. Trigonal bipyramidal means central atom is P here, here one Cl, here another Cl, this is the third Cl, here one will be above and one will be below. So this is the trigonal bipyramidal geometry that is associated with the PCl5. Is it clear, students? Okay, we'll move to the next question now. The next question, the pyramidal geometry. Now see that pyramidal geometry is associated with, okay, so if you see option methane, it is a tetrahedral. Okay, so we are not interested in this. Okay, if you see ammonia, there is a presence of one lone pair of electron, right? There is presence of one lone pair of electron. Actually in the case of ammonia, nitrogen is sp3 hybridization. Okay, if you see nitrogen, 1 2 3 hydrogens are associated with this, and in one of the fourth valency, there what happens, there is one lone pair. There is what? One lone pair. Okay, all are sp3 hybridized orbital. So this is sp3, this is sp3, and even this is sp3. Here overlap is possible with hydrogen, here also with hydrogen, and here also with hydrogen, right? So actual bond angle should have been what? 109 degrees 28 minutes, but because of the presence of lone pair, this bond angle will be this lone pair of electrons will be undergoing repulsion with bonding pair of electron, due to which the bond angle is 107 degrees. Okay, if it was 109 degree 28 minutes, it would have been tetrahedral, right? But now because of the presence of lone pair of electron, tetrahedral is undergoing change. That change is called as a distortion. Okay, and when it undergo distortion, the geometry is pyramidal in nature. So therefore it is option B. The pyramidal geometry is associated with what? Ammonia molecule. What about with respect to C? That is water molecule. The geometry is angular or bent, right? And if at all, if it is carbon dioxide, it is what? A linear molecule, because it is 180 degrees. Bond angle is what? 180 degrees. Is it clear, students? Okay, we'll move to the next question. Which of the following molecules is linear? Which of the following molecules is linear, right? So let us have this option A. Now option A is water C2H2. There are 2 carbon atoms and 2 hydrogen atoms. Okay, so C2H2, C2 and H2, right? Already we have learnt, and here there is a triple bond. So triple bond means this carbon is sp hybridization, this carbon is also sp hybridization. So the bond angle is what, 180 degrees. If it is 180 degrees, then the molecule is what, linear. The question is also what they're asking, which of the following molecules is linear. So option is what, option A, and the name of this compound is ethine, or it is commonly called as acetylene. What about B, tetrahedral? What about water, bent or angular? What about ammonia? It is pyramidal in nature, right? We'll move to the next question now. PCl3 is reactive because, I'm sorry, not PCl3, PCl5 is reactive because, okay, the first option, it is having 5 PCl bonds. Okay, it is having, but that does not make a sense that it is what, reactive, right? Second option, in its geometry, okay, is in a geometry, or in its geometry, the axial bonds are longer and weaker than the equatorial bonds. Okay, this is the correct option, our students here. Now why? Because we have seen this hybridization. So PCl5 is having the hybridization of sp3d, and its geometry is trigonal bipyramidal. And if you see trigonal bipyramidal means the central atom phosphorus is having what, 3 Cl atoms at the equatorial position. So this is what, the 3 Cl atoms at the equatorial. So one is above here and the other one is below, right? So these are called as axial. Okay, I will just highlight it by in this manner here. So this is axial bond, and this is what, axial bond. Okay, the axial bonds are longer. So we know that if the bond length is longer, then it is inversely proportional to what, bond strength. If bond length increases, bond strength decreases. If bond strength decreases, it is weaker, and if it is weaker, then PCl5 is what, reactive. Then PCl5 is what, reactive. Okay, so therefore we say that the axial bonds are longer and weaker than that of equatorial bonds. Now the question arises, which are equatorial bonds? So these are equatorial bonds. So this is one equatorial, and this is the second equatorial, and this is the third equatorial bonds, right? Is it clear? And if you see the option C, they have mentioned here it is a planar molecule. No, it is not a planar molecule. Why? Because these 3 Cl atoms are present in one plane. Okay, these 3, okay, I am writing here, these 3 are present in one plane. But if you see the other one, what, the Cl atom above, and this is what, below. So therefore it is not a planar molecule. Okay, and phosphorus involves one d orbital in its hybridization. Yes, it is going to involve one d orbital, but that is not the exact reason for PCl5 to be what, reactive. The exact reason is what, in its geometry, that is what, option B, in its geometry, axial bonds are longer and weaker than equatorial bonds. And we will move to the next question. In the next question, we can see that when ammonia accepts a proton, okay, now let us write here ammonia NH3, okay, it is having what, one lone pair, accepts a proton. Okay, so we have to write what, H plus. Okay, now see students, ammonia is accepting a proton. It means what, a bond is formed between the nitrogen and what, hydrogen, right? Under that condition, I can just write it as what, NH4 and what, plus. Okay, because lone pair of electrons are involved in a bonding with this H plus, that is what, a proton, right? So when a bond is formed here, nitrogen is having now 4 nitrogen and hydrogen bonds. So therefore I will write it as nitrogen, then I can write 1 hydrogen, this is the second hydrogen, this is the third hydrogen, and this is the fourth hydrogen, and a positive charge. Why? Because it has lost the lone pair of electrons, right? So if at all in ammonia, we already know that, okay, the bond angle is 107 degrees, but in case of ammonium ion, the bond angle is 109.5 degrees, or we can write 109 degrees 28 minutes. Okay, so there is increase in the bond angle, right? So if you see here, when ammonia accepts a proton in aqueous solution, because H plus are available in what, aqueous solution, right? And ammonia is water, liquid. Okay, it is also gas, but when we condense it, we call it as what? A liquid ammonia, right? So therefore we can say that in ammonium ion the bond angle is 109.5 degrees. So therefore if you see option A, the NH bond, okay, so this is the N and this H and this H bond angle changes from 107 to 109.5 degrees. That is correct option. Okay, this is one is correct option. Second option you have to concentrate, student, is that the S character of the hybrid orbital of nitrogen in both ammonia and in the product remains the same. Yes, it is 100%. Why? Because if I speak of the ammonia, okay, the lone pairs were present in what? sp3. Okay, but when a bond is formed with respect to proton, so the hydrogen will be present here with both the bonding electrons. Okay, so therefore the percentage of S of sp3 hybrid orbital of nitrogen atom in ammonia as well as in the product remains what? Same. So on the account of this, option C, that is both A and B, are correct. Is it clear, students? We'll move to the next question. In the next question, the bond angles of ammonia, ammonium ion and NH2 minus anion are in the order. Okay, so in all of these options, I hope you can see that it is greater. It means we have to write in the decreasing order. Okay, so decreasing means we have to predict first which is larger one. Okay, so larger one, here you can see that one concept you remember, students, as the number of lone pairs on the central atom increases, bond angle goes on what? Decreases. Okay, that we have to remember. Now here ammonia, there is one lone pair, but in case of ammonium ion there are no lone pair, right? So it is a tetrahedral. Okay, so if it is tetrahedral means the bond angle is 109.5 degrees, right? What about ammonia? So in case of ammonia there is one lone pair, right? And because of this lone pair there is a repulsion between lone pair and bond pair, and the bond angle is reduced from the tetrahedral angle to 107 degrees. Okay, right? And the shape is what? Pyramidal. Now what about NH2 minus? So NH2 minus, okay, now just try to understand, students. If it was NH3 and one lone pair, okay, now it is, what is happening here? So one hydrogen is lost. One hydrogen is lost in the sense what we can write it as N lone pair, one hydrogen, another hydrogen. Okay, and this was hydrogen. So this hydrogen is removed, but at the same time these bonding electrons are available with nitrogen. So therefore it is now having what? NH2 and what? A negative charge. It means again one more electron pair is present. So therefore still the bond angle goes on what? Decreases. So according to this explanation and this concept, we can say that the option B is the correct option. That is NH4 first, then comes NH3, and then comes what? NH2. Is it clear, students? In the last question of this video, students, here a very good question it is. Okay, they are asking molecular shapes of SF4, right, CF4, right, and XEF4. Okay, whether all are same or different. This is first question. Second question is that they are asking what are the number of lone pair of electrons that are present in SF4, CF4 and XEF4, and what? XEF4. Okay, now those who are very clever in thinking, right, so for them I would like to give one hint. So if you just consider this CF4, carbon is a tetravalent. Okay, carbon is a tetravalent. Fine. If it is tetravalent means what? The geometry of this molecule is a tetrahedral. Okay, and there are 4 CF bonds. Okay, there are no lone pairs. So no lone pair means what? I can write it as 0 lone pair. Okay, so respectively they are speaking. Moreover, in all of these cases they are speaking respectively. Okay, so under these conditions I want to concentrate CF with these 4 options, right? Now CF4 is a tetrahedral and number of lone pairs are what? 0. Number of lone pairs are what? 0. Under this condition I can just eliminate this option. Okay, this option I can eliminate. Okay, this and this I cannot eliminate. Then I can concentrate only with respect to what C and that of D. Is it clear now? Now I have to apply the formula, that is for SF4. For SF4, okay. So in case of SF4, I want to find out hybridization. So the moment I find hybridization, I'll get the idea how many lone pairs are available in that. So hybridization is equal to 1 by 2 valency of the central atom plus number of monovalent atoms that are linked with the central atom, then followed by minus if at all if there is cation, plus if there is anion. Okay, but it is a neutral molecule, so I will not consider this part now. Okay, this part I will not consider. Okay, so hybridization is equal to 1 by 2 valency of this central atom sulfur. Okay, how much it is? 6 it is. Okay, because it is coming from oxygen family, plus number of monovalent atoms, how many are there? 4 are there. Okay, so therefore it becomes 6 plus 4, that is what? 10. 10 by 2, that is what? 5, right? So this 5 is a steric number. Just concentrate here, students. 5 is a steric number. I will subtract something. What is that something? The number of bond pairs with the sulfur atom. How many are there? 4 are there. So 5 minus 4, that gives rise to what? 1. This 1 is nothing but what? A lone pair. It means SF4 molecule is having what? 1 lone pair. SF4 is having what? 1 lone pair. Okay, now if you see that, if you see the option with, they have mentioned here what? 2, right? They have mentioned here it as what? 2. So obviously I can eliminate this option A, then I can go with what? The option, that is what? Option D. Option D is what? Correct option, right? And if I want to correct myself, okay, with respect to other explanation, okay, that is with respect to XeF4, okay, I will calculate here hybridization of Xe, okay, with this formula. Hybridization is equal to 1 by 2 V plus M. Okay, there is no cation and there is no anion, leave it. So then becomes 1 by 2 valency of this xenon. Xenon is what? A noble gas. There are 8 are there. Okay, then monovalent 8 electrons, and then monovalent atoms, how many are there? 4 are there. That is what? Fluorine. So 8 plus 4. So 8 plus 4 is nothing but what? 12. 12 by 2, that is what? 6. So 6 is what? A steric number. But in this 6, okay, in this 6, okay, what I can say that I want to subtract what? The number of monovalent atoms. How many are there? 4 are there. So 6 minus 4, your answer is what? 2. So therefore there are 2 lone pair of electrons. Can you see here? There are 2 lone pair of electrons. So this is with respect to XeF4, and this 1 lone pair with respect to SF4, and we already know that in case of what? CF4, there is a 0. So the correct option is what? Option D. Okay, and this is a tetrahedral. Okay, CF4 is tetrahedral. SF4 is having which type of geometry? Seesaw. XF4 is having what? A seesaw. And if at all if you take XeF4, okay, so the central atom is Xe, then we are having here 4 fluorine atoms which are directed towards the 4 corners of water, the square, and 2 lone pair. One will be above and one will be what? Below. Okay, this is what? Square planar structure. Okay, this is which type of structure? Square planar structure. So therefore all are having what? Different. CF4 is tetrahedral. SF4 is seesaw because it contains what? 1 lone pair of electrons. Okay, if I write this structure here S, then followed by here 1 F, here 1 F, one will be having what? Lone pair, one will be above and one will be what? Below. One will be below here. Okay, so this is the structure of what? SF4, that is what? A seesaw. Is it clear? Thank you for watching the video, students. We'll be continuing in the next classes.